Welcome back. I'm Jason Grindstaff, and over the last few videos we've been looking at some statistic problems. In some of the first videos we looked at descriptive statistics, measures of central tendency, variability, confidence intervals. If you didn't get a chance to check out those videos, go check them out. We've also done another video on introducing this concept of probability. So those example problems really laid a foundation. Today's video, what we're going to do is we're going to start introducing the concept of combinations and permutations and using those to help us calculate probability. So before we get to combinations and permutations, let's review just real quick our basic and essential formula for calculating probability. In essence, what we're looking at with probability is the number of favorable outcomes divided by the number of total outcomes. So in that case, what we're going to be able to do is we're going to be able to calculate how often an event occurs. And so in the last video, we were looking at a standard deck of cards, how often we might draw a jack, or how often we might draw, if we drew two cards, a jack and a three, or in the case of the poker example, drawing its best possible hand, which was pocket aces. So if you didn't get a chance, go check those videos out before you push forward with this video. So to start out with this video, how about we use one of the same examples from the last video, and we actually introduce the concept of combinations. So when we look at combinations, let's just say that we have two males and three females in a group of five. Well, how many different combinations of groups of two could we get? Well, this video is going to help us better understand how to do that. So combinations is when we're trying to get that order, but actually order does not matter. So it doesn't matter in that example that we gave of groups of two. It doesn't matter if it's first a female and then a male or vice versa. Order doesn't matter in those combinations. But if it's a combination where order does matter, we call that a permutation. So in that case, it might matter if the female is first or if the male is first drawn. But let's look at what we mean by a combination. So a combination, you'll see it written as NCR, where N stands for the number of possibilities, and R is going to indicate the number of favorable draws from that. So in the case of from the last example that we did in the previous video, we were looking at the probability of possible drawing two aces from the deck. So if we wanted to calculate that with combinations, this Ncr formula, the way we calculate Ncr, and we're going to use that to recalculate the probability of drawing pocket aces, is it's n factorial, and a factorial, remember, so if we were drawing 4 factorial, that's the same thing as saying 4 times 3 times 2 times 1. So in this case, R is going to stand for how many times we want to draw that event. So if we said for our pocket aces, we have 4 aces in the deck, maybe out of 52 cards. So in this case, let's walk through our example problem of our pocket aces, and we'll use this combination formula and we'll kind of tease it out, but we're still going to be solving for the number of favorable outcomes out of the number possible. And let's see if we come up with our final answer of ace and an ace, and that should come out to be 1 out of 221 hands where that's the case, or 0.45% of the time. And let's see if we come up with the same answer. So how about we first, as we start this problem, let's look at how many total possible outcomes there are. So in that case, we're going to look at how many times can we draw two card combinations out of the entire 52 deck of cards. So in that case, we would write that out as 52 draw 2. So in that case, we've got 52 factorial over 2 factorial, and then we've got 52 minus 2 factorial. And so as we work this out, what we end up getting We're not going to write this all out. And then we've got 2 times 1 times 52 minus 2 would be 50. So we've got our 50 factorial. And in essence, what's going to end up happening here is we're just simply going to start canceling. All right, so this 50 factorial is going to cancel out with our 50 factorial up here. Our 2 will cancel out with the 52 and give us 26. So we're going to end up getting 26 times 51, which should give us a total of 2 card combinations out of a 52 standard deck of cards of 1,326. So there are 1,326 combinations of a starting hand, and that's going to be our number of total possible outcomes. So now we're going to solve for number of favorable outcomes of those aces. So instead of a 52 cards in the deck, we're looking for the combination. We have 4 aces, and we'll take any 2 of those that we can draw. So in that case, we've got our 4 factorial over 2 factorial times 4 minus 2 factorial. So here, 4 factorial, 2 times 1 times 2 times 1 factorial. So again, canceling out. Canceling out. So there we've got 2 times 3 is 6. So there are 6 possible 2-card combinations out of 4 cards. All right, so let's move on. So now we've got our numerator and our denominator. So in essence, what we're working with here is the number of favorable outcomes, 2 aces in our hand. There's 6 combinations that will do that. Out of the total starting hands of 2-card combinations is 1,326. And if we reduce that down, what we end up getting, our magic number of 1 out of 221 hands. And again, that's going to simplify to 0.45% of the time, or 1 out of every 220 hands. So this is how we begin working with combinations. Oftentimes I find it very helpful when dealing with probability and with combinations or permutations. Really take your time in working through these steps. Go back, rewind, push the pause button, and practice with this. If you missed a step, just rewind the video and go ahead and work through this. We'll have one more example problem that we'll work through in the next video to get a little bit more practice with this. But as I've said in the other videos, just keep practicing with this statistics. Over time, you'll get more and more of it, much like learning a foreign language. It just takes practice, so hang in there.